Hello everybody, and welcome back to Universe Sandbox 2. And the last time I did an episode of Universe Sandbox 2, we had a different president. So I decided to record Universe Sandbox 2 again because I've been seeing a lot more demand for it in the comments section. A lot more of where is Universe Sandbox 2? But then when I'm faced with these comments, I want to do it, but I run into the problem where I don't really have any ideas. But I have some ideas that have come to my mind that warrant a new episode of Universe Sandbox 2. So let's begin. For example, I want to know, whoa, did this get super, I can't tell, did this get more detailed? I know there's been an update, there's been one update, I think we're on Alpha 20 or something, there's been one update since I last recorded, but I think it's more back and stuff. I feel like things got a little bit more detailed, but I could be wrong. Not any more detailed, no, okay. Well, anyways, what was I gonna say? I want to try launching a bunch of Earths super far away from each other, but I want them to try and converge on one point, and I want to see two high velocity planet Earths or more converge and explode. I just want to see the violent reaction of what would happen if I just fired a bunch of Earths at Earth. So we're going to zoom super far out, and then we are going to I guess launch an Earth, launch velocity at 100 kilometers per second, but we're gonna pause. Okay, so I can launch an Earth right here. Okay, so one will launch at 100 kilometers per second right there. Okay, then we'll do this, and then we will launch another one at Earth from right here, and then we will come around and launch another Earth right here. And you know what? Let's just go up a little bit, launch another Earth right there, and then we'll go a little bit down, launch another Earth. You know, kind of just doing all directions sort of thing. And it should be, all of these Earths should be launching at the same radius. So I would think that they would arrive in the same spot at the exact same time. I mean, depending on fine adjustments with my cursor, you know, things could be off, but maybe gravity will help sync things in right at the last second. But we'll see what happens. All right, there we go. That looks like that's pretty fair. Maybe we need one. Actually, wait, no, I've already zoomed out. I've zoomed out, so I can't do anything anymore. I think they're all at the same radius. They should be. All right, and then we'll just watch them all get closer and closer and closer. Oh, shit. Oh, what? Wait, why is that one going faster? Or maybe it's just because it's really close to me. Oh, it's because it's close to me. All right. Don't miss. Don't miss. This is going to be a violent reaction. Don't stop it. Slow it down. Slow it down. I want to see are any of these going to end up hitting it. Okay, that's going to end up super far away. That's super far away. That's super far away. God, space is way too big. I mean, I'm pointing directly at the Earth, but look at that. Look at the error that results in Now one of them is going to end up colliding. Wait, I mean, those two are getting pretty damn close. Well, confirmed, all of them missed, but they did relatively converge all in one spot, and now they're all just gonna go off into space and go live happily ever after. And then this planet Earth, wait, where's the planet Earth that I was actually zoomed on? Did it actually start moving? Okay, so it actually did get influenced by gravity because it's moving now. Well, that was a bummer. How about we just do it a little bit closer? Let's do it a little bit closer. I just want to see if I was able to do that. Just make it the Earth's just fly at the, I want to see if I can actually manage to shoot an Earth super far away, like a solar system away, but that's clearly not going to happen. Okay, then we will pause, and we will just launch the Earth's super close, and we'll see what happens. Launching at 100 kilometers per hour. Boom, boom. Actually, I wonder if I do this in all directions, things will kind of it'll just stop moving. Well, I mean, I'm not going to get it. If I got it perfectly, like if these are all at the same radius and they hit the Earth from all sides, then nothing would happen because it would just negate the velocity. But I think things are going to be off where it's not going to be perfect. Yeah, like you can see, they're not 100% on the lines, although they are kind of offset relatively the same way. We'll see what happens. This seems like 2001. Okay, I feel like the lighting definitely changed. The lighting seems way more detailed, but I could be, maybe it's just been a while since I've played, but the lighting seems a little bit better. It looks pretty. Maybe it does. I've spent too much time away from this game. Slow it down. Bum, bum, bum. Sandwiched Earth. Wait, are they actually going to deflect each other, or are they actually going to absorb? I would think everything would absorb. But if you look, it's not flinging off anywhere. It actually is kind of just staying in the same spot. I mean, as you can see, it's drifting off in this direction, but that's just the error in my placement. Well, that's what happens. When 4 or 5, we had 5 Earths. Yeah, now we have 3. When 5 Earths are placed like that, 4 of them are launching at the center one at 100 kilometers per second. Yeah, precisely that. Precisely. If we just keep adding experiments onto experiments. Okay, now we got, oh, what's that, blue hot? Yeah, there's some stuff that has changed. I don't remember this blue hot. Because I know you can get white hot. I mean, there's also stars that will glow blue hot, but this is different. This feels different. I feel so rusty at this. I'm like, God, it's been so long since I've done this. I'm just sitting here clicking around. All right, I want to see how, I'm gonna really slow down time here. I'm gonna see how close okay, here's what I'm gonna do. I'm going to launch, is this at 1,000? I want to do 10,000 kilometers per second. 10,000 kilometers. Oh, I can only do 1,000 kilometers per second. Okay, whatever, 1,000 kilometers per second then. Maybe that, no wait, no, yeah, I can do, yeah, 1,000 kilometers per second. I'm gonna launch an Earth as close as I can to this star right here. I'm gonna see if it can survive. It's 39 seconds per second, we'll do 23 seconds per second, okay. Okay, there it goes, there it goes. Oh shit, Jesus Christ, that was super far away from this thing. This is just a big star. All right, we'll launch an Earth right here then. Oh, will it burn? Okay, slow down the time, or maybe it already burned up. Has not burned up yet. We'll see how long it can survive. Is it still, it's just dark. There we go. Wow. I guess all the ice caps have frozen over, so it's just kind of flooded. I feel like all the water would have boiled by now. So we're just gonna do a quick flyby of this star. Hopefully we don't get sucked in. Maybe we can escape the gravity. Maybe we'll just skid by. Oh my God. Don't get sucked in. Whatever you do. Oh my God, I think it actually is doing a bit of a gravity assist. Is it curving around? No, it's not. Wow. Quick flyby. And then I think we'll survive because now we're getting further away. I think that one's just gonna straight up crash into it, but I could be wrong. Maybe it's just gonna go by. Let's check. Let's jump over to this one. Are you just gonna skirt by? It is. I want to see if I can get closer to it. Oh my God, I feel like it's gonna crash, but it's not. No! My God! Survive, survive. Okay, any gravitational assist? It did not affect it at all. Okay, I want to see how long it'll take for it to actually curve, or what velocity that I can do it at where it will actually somewhat curve it. I'm gonna launch it right here, right there. As it gets that close to it, maybe the Earth will be able to survive. Whoa, with a close encounter! Come on, now you just gotta get a good enough distance away. Mission to escape the star. No, God damn it. You were so close and we're moving so fast away from it. Okay, so what if we get a star flyby? We'll get the sun. Although this could be dangerous because I'm gonna end up supernovaing everything, but okay, so this is sitting at, I'm pretty sure 10,000. Okay, we'll do 100,000 kilometers per second. The sun doing a flyby, and we'll make this move super slow. Okay, 15 seconds per second should be fine. Okay, 100,000 kilometers per second. Our sun doing a very, very, very close flyby of an even bigger star. It seems to be breaking the lighting physics of the game. Okay, please do not cause super. Oh, it's gonna fucking crash. It is gonna. Oh my God! So we have a supernova happening but it's actually not going to trigger the big star to do a supernova, or maybe it's just on the cusp of doing that, because that seems like that would be something that would cause something like that for the big star. Oh wow, the supernova is just going to fling into space? Oh, that's the remnants of the sun. Jesus Christ, it just skidded. Oh wait, did we lose a star? Oh, we did. We did lose it. Okay, that makes sense now. That's cool though. It's cool that we see the fragments of the sun just skirting by. I want to try that again, but I want it to be successful. Okay, so I'll give it a little bit of buffer room. I'll launch it right here. Oh shit! Wow, that went really fast. Okay, let's try that one more time. That is a rocketing sun. Okay, 34 seconds per second, 100,000 kilometers per second. Launch right here. All right, please don't supernova. Can the sun survive? I mean, we already know it can survive because we just did it, but super fast. But I want to see it happen super slow. The closest two stars have ever come without supernovaing. That's still probably like millions of miles. Well, that's probably like 1,000,000 miles right there. maybe a little bit less than that, but still, it's pretty damn crazy. I would definitely say. Okay, it survived. Now, what about a black hole? I mean, what's the mass of this right here? This is the mass of 21 suns. What if I got a black hole skirting this? Will it cause anything weird to happen? Normally, it's the black hole sucking things up, but right now it looks like it's the sun sucking up the black hole. This seems like it's not physically accurate. Why would this happen? What kind of situation is this? A black hole orbiting a star. I'm going to launch a random asteroid at Earth, but I'm going to launch it at 1,000 kilometers per second. I'm going to see the effects on the Earth when it gets insanely close to the atmosphere, and skirting by at 1,000 kilometers per second, what it does to the tidal effects. So let's slow it down. Slow it down substantially, because this is going to whiz by and you're not going to see anything. Okay, this is 2 seconds per second. Will that be enough? Maybe it will. Okay, and there it goes. Just a little asteroid. Woo! Let's get one just a little bit closer. Let's get one that actually goes into the atmosphere. Maybe it'll burn up. Maybe it won't. Look at that shadow. Whoosh. Shit. Just goes right through the atmosphere. All right, and now we will speed it up, and we'll see if that has any kind of effects. 2 asteroids skirting by at that speed. 14 degrees Celsius. I am disappointed. I am very disappointed that happened. Okay, maybe it has to be a little bit more massive. Actually, it got colder. Nothing happened. Everyone was just like, what the hell was that? Okay, how about this? We'll launch the moon, and it will just skirt by at this distance. I think it will just clip the atmosphere. Let's not do the minutes, because it's going to be launching at 1,000 kilometers per second. Okay, this is going to be in the milliseconds. Okay, and we'll just skirt by like that. Oh my god. It's very slow. Remember that. 73 milliseconds per second. I hope it doesn't get sucked in. Do not get sucked into the planet. 1,000 kilometers per second. It should just skid right by. Oh my god! And look at that shadow! Is it heating up yet? The surface temperature of planet Earth is currently at 156 degrees Celsius with those kind of tidal forces. Yeah, because really at this distance, if the moon was orbiting at that distance, it would get torn apart. So probably if that happened, you would just see water rise up into the sky. You would see the greatest tsunami you've ever seen in your life. Maybe it would just rip the land apart. Florida would probably be gone. Maybe that's an exaggeration, but earthquakes like no tomorrow. Okay, let's speed that up. That is now rocketed away. Are there any more insane effects? Is it gonna get any hotter? Is it just gonna stay at 156? Oh, there we go. Oh, okay. So if the moon skirts by the planet at 1,000 kilometers per second, you're gonna lose your oceans. I want to try that again. I really want to try that again. That was cool. We'll just kind of keep speeding up the Earth like this. The Earth is getting hotter and hotter and hotter. Who knew that you can... Oh my god, look at all those moons. They're just rocketing away like that. Jesus Christ. Okay, now let's see the current motion of the Earth. It's still at 23.9. I don't know. I think that would speed up the planet. Right now, things are roasting. We are seeing the oceans move away. Or not move away, they're melting away. Oh! And that's what would happen. And I think we've also set a little bit of motion to the planet just because of all the gravitational effects. I think all those moons are colliding into each other, by the way. And my question is, what if this is the answer to all the problems with Mars? What if we launched a moon? I mean, we should probably extend the time of day on Mars, so we should launch this in a retrograde fashion. What if we just did this, sped up Mars? Okay, so we just launched it super close. Maybe that'll heat up the planet. Climate is minus 31 degrees Celsius. Okay, so maybe we need 2 moons here. A little bit closer, a little bit closer. Speed it up, minus 19. Okay, more moons. Keep speeding it up. Oh, it just clipped it. Sorry. Ah, clipped again. Sorry. Really damaging the planet, but you know what? Maybe it needs that a little bit. Okay, now it's 5,000 degrees. I think we just ruined Mars. Well, then you know what? I will try and stop Mars's spin by just skidding it. Let's just skid that. Boom. Boom, 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 boom. Did I do it? We're going at 15 days per second. I totally just stopped Mars's spin. I want to slow it down even more. Boom. Oh, well, now it's super... Okay, I think it might be just a little bit slower now. Wow. That's gotta suck. So I think to top it off, we're going to have the Andromeda Galaxy, and then where's the Milky Way Galaxy? Is the Milky Way Galaxy seriously not an option? I don't see the Milky Way Galaxy. Okay, we'll just have 2 Andromeda Galaxies. I have no idea what will be an appropriate velocity for this. But right now, there's 1,000 kilometers per second, 10,000, 100,000, 1 million, 10 million kilometers per second. And we're going to make this move super, super slow. And we're going to see what happens when 2 galaxies, or at least 1 galaxy is stationary and then 1 galaxy just whizzes by the other. Supermassive. Jesus Christ, the supermassive black hole is just going to whiz by like that, but will it cause it to do anything substantial? Come on now. If I can't launch this, then I'm just gonna have it orbiting, and then I'm going to try and change the velocity of the supermassive black hole. So let's see if we can get... Okay, so the speed is at 61 kilometers per second. Well, then I'll just change it to 1,000,000 kilometers per second. This shouldn't be launching, but I hope the galaxy as a whole will move along with the supermassive black hole. But we'll see. No, the supermassive black hole is just gonna detach from the galaxy itself. Whatever, I guess we'll watch a galaxy collision because I can't seem to get that working correctly. Go very, very slowly. I've never done a galaxy collision on here anyways because it's always so laggy. Galaxies are kind of finicky in this game, so I haven't played around with them too much. Otherwise I would, because I can't even speed this up anymore. Otherwise it's just gonna go, can't move anymore. Oh, and there it goes, and then it becomes 1. And fun fact, there will not be many casualties in the middle of all this because space is just so huge. Most things won't even touch. They'll just seamlessly go through, and they'll just affect all the orbits of the individual stars, and it'll result in a big dance. And then we'll go out and in and out and in and out and in, and eventually things will settle down and become 1 big galaxy. Maybe the black holes will eventually collide. I don't know what would happen if the black holes combine. Maybe everything will just explode in the very end. We really don't know. Unless maybe we do have pictures of galaxies that are currently colliding. All we know is the Andromeda Galaxy is going to kill us all in billions of years. But actually, I think the sun would kill us before then. We'll see. Anyways, hope you guys have enjoyed. Maybe I'll do some more of this stuff if an update comes out, or if another grand idea pops into my head, or if you guys think of some for me, so I don't have to do that. We'll see what happens. So I will see you guys later. The theory of it is still true that everything has a gravitational pull. Like even yourself, it's very, very weak. It's a very, very weak force, but it is still there. Let's go into, I don't know, minor objects, and let's get Halley's